Welcome back to PMAT0028. So in the previous video we learned how to multiply and divide rational expression. In this video we continue with chapter 12. We will be covering section 12.3 and 12.4. In this section we will be learning how to add and subtract rational expression. Section 12.3, 12.4, adding and subtracting rational expression. Okay. So on the first part, I want to talk about how to add and subtract with same denominator. Okay. Back in the day, when you learn how to add and subtract a fraction with the same denominator, what you have to do is you just keep the denominator, right? And you add the numerator together. For example, like what if you want to add like 1/2 plus 5/2, right? You keep the denominator, which is 2, and you add the numerator 1 plus 5 6, then you simplify it. Okay. Similarly, when you add and subtract a rational expression with the same denominator, you just again keep the denominator and you add the numerator together. Okay. The only difference is that when you add the numerator together, it's not just number, right? It is like combining like term. It's like combining like term. And the denominator is you keep it. You're not touching that. But on the top, you add a combining line term. After you combine that, you have to see if you can simplify that or not. For example, what if I have 2x over y plus x over 3y. Okay, so you have two rational expressions. Okay, the denominator the same, so you just go ahead, keep the denominator, and you're gonna just combine the numerator together, and you see that because this is similar, so 2x plus x is 3x over 3y. And you can simplify it because 3x and 3y you can cross out number 3, so your answer is x over y. Okay. So this kind of very simple problem when numerator is a very simple algebraic expression. What if I have like this? What if I have 3x squared minus plus 2x, I'm sorry, over x minus 1 minus 10x minus 5 over x minus 1. And you see that this is the same denominator, so I'm going to keep the denominator. And you're going to subtract each other, so you have 3x squared plus 2x minus, because you see that this is the minus of the whole thing, so make sure you gotta put parentheses. If it's addition, you don't have to put parentheses, but if it because it's the minus, you have to put parentheses. Then you're gonna distribute the minus in, so you have 3x squared plus 2x minus 10x plus 5. So you see that if you don't have the parentheses, your answer will be wrong, because in that case it will become minus 5 instead of positive 5. Okay, so after you distribute it, you can combine items. So 3x squared, you keep it, 2x, so this leave you negative 7x plus 5 over x minus 1. Okay. Alright, right now you have to check if you can simplify this or not. Oh, I'm sorry, this is 8. Okay, so on the top you have trinomial, so let's see if it is factorable or not. Okay, so you have 3x here and x here, and factor of 5 just negative 5 and negative 1, or positive 5 and positive 1. So I'm going to put negative 5 and negative 1 here, because after you draw a smiley's face, it turned out to be negative AI. And you see that the top and the bottom is similar, so you cross them out. So you have 3x minus 1. Okay. So you see, when you add and subtract rational expression with the same denominator, it's like you add and subtract fraction with the same denominator. You just do a few more steps that sometimes you have to factor the last the answer to simplify more. Well, I mean, when you add and subtract fraction, you still have to simplify, right? Remember? So either way, you still have to simplify. Alright, let's do one more example with the same denominator. Example 3. What if I have this? What if I have 3x minus 1 over x squared over x squared plus 5x minus 6 is x squared minus, or the plus, so let's do minus 2x minus 7 over x squared plus 5x minus 6. So you see the denominator the same. Denominator the same. So I'm going to keep the denominator. And I'm going to just combine the numerator together, and because this is minus, so make sure you put parentheses. Same for this guy, you see. Then you distribute it. Keep the denominator. Then you combine like term on the top. Alright. Negative 1 plus 7 is 6. 3x minus 2x is x. Okay. Alright. Then you have to check if you can simplify this. At the bottom we have trinomial, so let's see if it is factorable or not. So this x, right? So it would be negative 3. If we put negative 3, negative 1, it won't work, right? Negative 3, negative 2 is give you a positive 6, so it should be plus 6 minus 1. Alright, plus 6 minus 1. And you see that? You can cancel them out. So what you have left is x, 1 over x minus 1. Okay. So you see the concept of factoring is important, right? Because you see that everywhere. Later on, you're going to see that again. You mean? So make sure you grasp all the concept of factoring. G-shape, factoring, difference of square of the sum, square of the difference. You must grab it. Okay? Because if you stop right here, it's not complete. You have to do one more step to get the simplest form. Okay, good. So that is when you add in and subtracting with the same denominator. The second part, we will be learning how to add and subtract with different denominator. Different denominator. If it is different denominator, what you have to do, you have to find LCD. That's the goal. You have to find LCD. But before finding LCD, you should factor all denominator as much as you can. If you can factor the denominator, that's fine, but if you can, you must do it. Okay? You must do it. And you find LCD, least common denominator. And of course, this is rational expression, so it's kind of harder than finding LCD for number, but the concept is kind of the same. Alright, for example, this. Let's say, what if I have these two rational expression and I want to add them together? Okay, example 1. We have t minus 10 over 2t squared added to t plus 5 t squared plus 3t plus 2. So you see that the denominator is different, right? It's 2t squared plus t minus 6 is different from t squared plus 3t plus 2. So you have to find LCD. Okay, but before finding LCD, you have to factor. Try to factor everything out. Alright, so I'm going to keep the top, the bottom I factor them. Let's see if we can factor that or not. Okay, so it should be 2t, t. So give you 3 and 2, right? 6 is, factor of 6 is 3 and 2. So let's see where we're going to put that, so that you, after you draw the smiley face, give you positive. So should be negative 3 here, 2 here. And over here t, so it will be 2 and 1. That's easy. Okay. Alright. So all the numerator is in factoring form, so you have to find LCD. So the LCD will be what? The process of finding LCD is to make it to make the rational expression have this, to have the same denominator. Okay, so the LCD, you're gonna take everything. So you're gonna take t plus 1. You take all of them, t plus 2, and 2t minus 3. Alright. Alright, so after you got LCD, so you see that this is missing t plus 1, right? So I'm going to multiply the top and the bottom by t plus 1. Okay, and over here you missing 2t minus 3, so they don't have 2t minus 3. You see, LCD is 2t minus 3, but they don't have it, so I'm going to multiply the top and the bottom by 2t minus 3. And now what we have the same denominator already, right? The same denominator, so I just keep the denominator. Okay, keep the denominator, and you just add the numerator together. Okay. Alright, so you just void them because you need to combine like terms, so you have to void them. So void them. So t squared plus t minus 10t minus 10. Everybody know how to void them, so give you 2t squared minus 3t plus 10t minus 15. Because if you don't void them, then you cannot combine, right? So you have to void them. Alright, so then you combine like term. So t squared plus 2t squared is 3t squared. This is give you negative 9t. So this is give you, so this is negative 10t, positive 10t is gone, so this is negative 2t, right? And this is give you negative 25. Alright, question is, can we stop right here or we can factor? Well, on the top you have a trinomial, so you have to check if you can factor the top or not. Okay, let's check. Let's see we can factor the top. Let's see. So you have 2. Well, you can work on scratch paper to see if you can factor the top. Okay, so you have 3t squared, so it was 3t and 1t. You see that there's no 3t over here, but they have t over here, so probably it work. So let's work on the scratch paper. So you have factor them. So you have 3t here and t here. Factor of 25 is 5 and 5. Don't work. I don't think so. 5 and 5, 25 and 1. 25 and 1 doesn't work, I'm sure. So 5 and 5 here. No, it's not working. So just leave it like that. Okay? Because you see, after you draw the smiley face, never giving you negative 2t, so it doesn't work. Okay? Alright. So we're gonna keep like that as the final answer. Okay. I can give you another example. Different denominator. Okay. What if I have something like this? Let's see. Alright. What if I have this? What if I have 6x over x squared minus 4, you subtract by 3 over x plus 2. You see that is we have different denominator already, right? But it's not in we have not factor the bottom yet, so I'm gonna factor as much as I can. So this is different of square. So 4 is 2 squared, so different of square, right? So x plus 2 times x minus 2 minus 3x plus 2. So what would be the LCD? The LCD will be what? So in order to have the same denominator, you're gonna multiply over here by x minus 2 and the top by x minus 2, right? So the LCD must be x plus 2 and x minus 2. Okay, then my expression will become 6x plus 2, x minus 2 minus 3, so I multiply the top and the bottom by x minus 2. Okay. Remember that in order to add or subtract different denominator, you have to do some way somehow to get it the same denominator, right? So right now I multiply the top and the bottom by x minus 2, that they have the same denominator. Then I keep the denominator. Then I just combine them. Just combine them. Alright. Then I void them, so 6x minus 3x plus 6 over x plus 2, x minus 2. Right? 6x minus 3x is 3x plus 6 over x plus 2, x minus 2. Can we stop right here? We gotta check if we can simplify that. But in order to simplify, we have to factor, remember, right? So we have 5g shape here. So 3x plus 2, right? 5g shape, 3 taken out. So you have x plus 2, x minus 2, right? Then I simplify that. So what you have left is 3 over x minus 2 as the final answer. Alright. So in section 11.3, there's a part, I'm sure that you can see that in homework, there's a part that it trains you how to find LCD. finding LCD is easy. I mean, you just take you just take all of them. You take all the different denominator, and you have to take the highest exponent. Okay, remember you find LCD for two number. That's what you do. Okay. Then you just on the homework you practice on how to find LCD. As soon as you know how to find LCD, then you know which one you need to multiply the top and the bottom. Okay. All right. Let's do another one. Let's do another one. Let's do another one. What if I have something like that? Let's do on this side. Oh, let's skip. Let's go on another page. What if I have this? What if I have I have 7x minus 3 minus 9 3 minus x. Okay, so in this case the question is, do we have to find LCD? Well, x minus 3 and the other one 3 minus x. It looked the same already. It's not 100% the same, but I mean, if you do one more, so remember in the previous session, remember I showed you how to factor -1 out, then you can switch position. So in this case, if I factor -1 out, so that I can switch the position between 3 and x, and I can put the negative on the top. So negative 9 x minus 3, right? And what we have the same denominator. See that in this example you don't have to find LCD. You just need to factor, and then it become the same denominator. And now it is same denominator already, so I'm gonna just keep the denominator. I'm gonna just go ahead add them up, so become positive. It will be 16 over x minus 3. Okay. Symbol 4. How about this one? 2x over x squared plus 2x plus 1 plus x over x squared minus 1. Okay, you see that we have different denominator, so I'm gonna factor all of them together. Factor all of them. So this is I can factor this is square of the sum right here. So the 1 is 1 square, 2ab. So this is nothing but x plus 1 square, right? And over here this is the difference of square, so this is x minus 1, x plus 1 times x minus 1. Alright, so how I'm gonna find LCD here? See, we're gonna take all different factors, so we have two factors over here, x plus 1 and x minus 1, right? X plus 1, x minus 1. However, the factor x plus 1, we have the highest exponent, so I'm gonna take the highest one, and the factor x minus 1. So that's gonna be your LCD. Okay, that will be your LCD. Alright, so if you compare the LCD with the denominator over here, you see that the denominator don't have the x minus 1. So you have to multiply the top and the bottom by x minus 1. Okay, and the denominator over here don't have. Over here we have square, so it missing another x plus 1. So I multiply the top and the bottom by x plus 1, then it give you x plus 1 squared and x minus 1, right? Alright, so I'm going to just stop a little bit here for you to process. Okay. Alright, See, I multiply the top by x plus 1, the bottom by x plus 1. So x plus 1 times x plus 1 give you x plus 1 squared. Okay, now we have the same denominator. So we have x plus 1 squared, x minus 1. And we're going to combine together. So 2x, x minus 1 plus x, x plus 1. Then I'm start folding up. So 2x squared plus 2x plus x squared plus x. So I fold them. And the bottom, I just keep it like that. Then I combine like terms. So give you 3x squared plus 3x, right? Over x plus 1 squared, x minus 1. Okay, can we stop right here? Well, we got to check if we can simplify that. In order to simplify, remember we have to factor. The bottom is in factoring form already, but the top is not factored yet. So you have to find GCF. So that's GCF. So you have x plus 1 outside. And now you see that the top and the bottom are kind of the same, but this is square. Okay, so you just cancel 1, so you still have 1 x plus 1 at the bottom. 3x you're going to keep it because you cannot cancel with anything else. X minus 1 the same, you cannot cancel with anything else, but it's x plus 1, so you cancel. So you still have 1 x plus 1 left because it's x plus 1 square, x plus 1 times x plus 1. You see that? You cancel, so you have x plus 1 left. Alright, and let me see if I factored them right or not. I might get something wrong. I'm gonna check from the bottom because I don't know, I just feel like I got something wrong. Oh yes, oh, something wrong. See, so this minus, so this give you negative 2x plus x is negative 1x. Okay, so I factor them out, so give you negative 1. Okay, okay, so you cancel this, you cancel this and this. Okay, so this and this the same. Alright, so your answer will be 3x over x plus 1 squared. Okay, it's minus, okay, I'm sorry, it's minus. So distributed 2x times 1 is negative 2x. Okay. So that is that's the way how you adding, subtracting rational expression with the same, with different denominator. You have to find LCD. Okay, you gotta bring it to the same denominator, then you can add and combine. You subtract. If it's not the same denominator, then you cannot do it. Okay. All right. All right. So and the way you're finding LCD is you're gonna take all factor, and you take the one with highest exponent. You compare. Okay. If you guys forgot, you're gonna go back and try to review how to find LCD for 2 number. Remember how to find LCD for 2 number. It's not a part of this course because that is you're supposed to know that already. Then after you review how to find LCD for 2 number, then you should be able to find LCD for 2 expression. Okay. Alright, so I'm gonna stop section 12, chapter 12 over here. I'm thinking about if we have class for week, face-to-face class for week number 9 or not. I will send you guys email. I'm sorry for saying that because this is I'm talking for PMAT0028, and this this is online course. But if it's not online course, then you still have class. Okay. Yeah. So I'll in the next video I will be talking about chapter 13. Okay. Then I'll see you next time. Bye bye.